Hi there, welcome to this third video in the Unit 40, all about probability. We've been looking at experimental probability, we've started to look at the language of probability, and now we're going to start to look at a visual representation of being able to calculate some probabilities, and that's using tree diagrams. In order to see how it fits into the overall topic, this particular video is going to cover this section, so independent events and tree diagrams. We're also going to look at combining some events together, so using the and or rules, and we're also going to link in some conditional probability. So this is a big one, and you need to make sure that this, of all the topics that we've done so far in probability, this is the one that's really going to kind of set you off, moving up into those higher grades if you can master this skill. Okay, so quick true or false to start with. Just to get us back into the swing of things in terms of probability. So to start with, you're equally likely to get heads or tails when flipping a fair coin. Yeah, that's true. Okay, you're more likely to get an even number when rolling a fair die. Okay, that's false because you've got equal probability. Probability of picking a red card is 2/3. Yep, that's true because you've got 4 reds out of 6, and 4 out of 6 is the same as 2/3. Probability of landing on a 1 on the spinner is 1/4. It's false simply because there is no 1 on there, so that would be 0. Probability of not picking black is 4 out of 6. So not picking black, well, yeah, okay, true, because you've got 4 reds out of 6. And finally, the probability of choosing an A from the word mathematics is 2 out of 10. Okay, and a quick count up should have been false because there are 11 letters in total, and we've got 2 A's from 11, so 2 out of 11, not 2 out of 10. Okay, hopefully you've done quite well on that first bit. Okay, so this is what a probability tree is going to look like. We are going to be able to see from here all of our different options. So a little bit like in life where you take one path rather than the other. First choice here, we've got some things that are red, and then maybe a second choice that are red. Notice how these probabilities, the outcomes go at the end. So the actual categories at the end. Also notice how we've got the probabilities on the line of each thing happening, and these two things here are exhaustive, so they add up to 1. It's really important that as you're looking down your branches, the pairs of branches, or every now and again you might get 3, they add up to 1 whole 1. Equally here, that adds up to 1 whole 1, so does this one. And again, we're sticking with the same notation. Try and stick with, if you go red and blue on the first branch, stick with red, blue, red, blue. It's not that it's wrong if you do it the other way around. It's just, you end up making mistakes. It's confusing. So try not to do that. Okay, so probabilities for each event are shown along the arm of each branch, and they add up to 1. I've mentioned that already. And here, the ends of the first and second level branches show the different outcomes. It'd be important for you to get this bit in your book, so do that bit now, please. Okay, then we'll do an example. So Rebecca has 9 coloured beads in a bag. 4 of the beads are black and the rest are green. She removes a bead at random from the bag and notes the colour before replacing it. Again, we need to be looking out for these words. Whether they're replacing it or not is going to be really, really important when we do our tree diagrams. She then chooses a second bead. I'm also going to mention at this point that choosing one and then putting it back and then choosing a second is one thing you might look out for. A similar thing is picking one out, not putting it back, then choosing a second, which is different, obviously. And then the third thing to look out for is choosing 2. Now, choosing 2 is exactly the same as choosing 1, not putting it back, and then choosing another in terms of the mathematics that we're going to be looking at. Okay, part A, draw a tree diagram showing all possible outcomes, and then part B, calculate the probability that Rebecca chooses 2 greens and then a black followed by a green. So as we do this, first choice, black or green. You don't have to write it in different colours, but I'm just using that to demonstrate. let's get the probabilities in. So 4 out of 9 because she had 4 beads that were black and the rest of them were green, and there were 9 in the bag. So 4 out of 9, 5 out of 9 here. Again, these should add up to 1. Second choice, black, green, black, green. So as you come down this branch and you've chosen black, the next choice could be black or green. If you've come down this branch and you've chosen green, again it could be black or green. Probabilities stay the same because the bead has been looked at, written down and then put back in the bag. There is just the same chance of it coming out a second time as it did first. Then, if we're looking down this branch, we've got the probability that it's black and the second one is black. Black and black. We need to be very precise with the language we're using here. Again, when we're talking about probability, and means to multiply the two things together. So and we're multiplying. Black and green. Notice I'm multiplying 4/9 and 5/9. I'm not trying to cancel any of these down, by the way. We'll see why later on. Green and black. Again, multiplying because we've got and finally green and green. Now, once we've put all the possible outcomes, answering the second part, part B, is going to be dead easy. So 2 green, that's green and green. So that's going to be 25 out of 81. A black followed by a green. So black and then green is 20 out of 81 here. Okay, and so once you've got your tree diagram in place, you've multiplied down your branches, you've written down all the possible outcomes, then you can start to answer the questions that are being asked. Again, pause the video if you want to draw this out, get it down in your book, write down the questions, take your time over it, get a really good example down. Okay, second example then. Peter has 10 coloured cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag, notes the colour but does not replace it. He then chooses a second cube at random. Draw a tree diagram showing all possible outcomes and then do some calculate probabilities of various things afterwards. So in terms of what's happening this time, 3 cubes are red and 7 are blue. Fine. So we've got 3 out of 7, 3 out of 10, and we've got 7 out of 10. Now this time we are not replacing it. So if we've chosen a red one, and the probability of choosing another red, well, I did have 3 reds, so I'm now only going to have 2 left because I've already picked one, and I did have 10 things in total. I'm now only going to have 9 things. We remember that these 2 branches add up to one whole one because they are exhaustive. So 2/9, and this one's got to be 7/9. And then moving this way, if I chose blue first, I've still got 3 red ones left, but I've got 1 less thing in total. And again, we're bearing in mind that these 2 things add up to one whole one, so 6 out of 9. The next step is we need to work out the probabilities of all the things happening. So red and red, red and blue, blue and red, blue and blue. Again, remembering that when we're saying and, we are multiplying. We do all of this before we go into part B. Okay, part B, calculate the probability that Peter chooses 2 reds. So red and red is this first one, 6 out of 90. Don't worry about cancelling it down, we don't need to for probability. And again, a blue cube followed by red. So blue and then red, 21 out of 90. Okay, good. Again, you might want to pause the video, make sure you've got all this information down. This is obviously different to the last one because it says does not replace. It could equally have said at this point, picking 2 out. So he chooses 2 cubes. The tree diagram here would look exactly the same. So I've already mentioned the word and in some detail before. We're going to look at the actual rules here, the and the or rule. So calculate the probability of picking 1 milk chocolate and 1 dark chocolate in any order. Now the rules that we're going to look for are milk and dark because it says in any order. All the other questions that we'd had so far said one thing followed by something else. But this, it doesn't care. We can have milk and dark, or we could have dark first and then milk afterwards. So as we've been doing, milk and dark, we're multiplying these two things together. Dark and milk, we're multiplying them together. And these two things are mutually exclusive. So again, from a previous video, you'll remember mutually exclusive means they can't happen at the same time. We can't have got milk first followed by dark, and also dark first followed by milk. That doesn't make any sense. But both things could have happened separately. So because they're a separate thing, we're using this word or. So this could have happened, or this could have happened. And the maths that we're using are and, we are multiplying, and we're multiplying, and then we need to add the two things together. Be really careful here that you make sure you do this as a sum and then this separately as a sum here, and add the two things up. Remember, we've got order of operations going on. Multiplying comes before adding. You should end up, try it on your calculators, but you should end up with this value. If you get something else, then make sure that you put brackets around these first of all, just to make sure that your calculator is doing it correctly. Okay, hopefully you've got enough notes now to be able to give this a go. If not, just rewind the video, make any more notes that you need, and then there is a Word document attached, a worksheet attached to class charts. So you need to have a look at that. You can open it up on your phone or your laptop or whatever device you're using. If you want to fill it in electronically, you can do. However, this one I would absolutely recommend you do it in your books, because drawing out the tree diagrams electronically is going to be a bit of a pain. So do it in your book. If any questions, or you want to send me a picture of the work that you've done, if you've got any questions in terms of why you're not getting the right answers, feel free to do so. The answers are on the next slide, so you'll need to pause the video now. Okay, and here are the answers. So for question 1, I've drawn out the tree diagram like it's asked. So make sure that you're looking at your branches, that they're the same as mine, that the values, the probabilities are equally the same as the ones I've got here. You might have done blue and red, maybe the opposite way around. That's perfectly fine, but stick to the same notation. So if you've done blue first and then red, make sure up here you're also doing blue then red. Now we were asked for any order, so I've done red and blue. I've done blue and red, and I've added these two things together to get 24/49. Second time was without replacement. So red, notice how it goes down by 1 top and bottom. These two branches add up to 1. Blue goes down by 1 top and bottom, and these two branches have to add up to 1. Again, red and blue in any order, 12/42, 12/42, and adding them together gets us 24/42. If you've cancelled it down, fine, but you don't need to. And the answers for question 2, again, I've drawn out my tree diagram like it suggested. These were all without replacement, so we weren't putting anything back in. We've got purple and green. Notice my purple goes down by 1. My green goes down by 1, and my branches add up to 1 whole one. Both green I've done down here, so green and green, multiplying the two probabilities together. Then we did purple and then green, so purple and green this way, multiplying them together, and the probability that they're both identical. So we could have had purple and purple, or we could have green and green. Notice I've put mine in brackets here, calculating them separately, and then adding them up at the end. Make sure you green pen these, give yourselves plenty of praise if you've done this well. This is not a particularly easy thing, although once you've got it, once you've got it to this point, if you start to get lots of it right, you'll not go far wrong from here on. So well done. Finally then, extra work. As ever, I'm going to set some exam questions on Dr. Frost Maths for you all. If you want to do something elsewhere as well, you can do. Corbett Maths will have some worksheets that you'll be able to do some questions on, as will BBC Bite Size. Make sure you're looking for the keywords which are probability trees or probability tree diagrams. Okay, so thanks for watching again. The more and more people are starting to get in touch, so I know that you're doing these, and I'm getting some positive feedback from you, so that's good as well. Any questions that you've got, or anything that you'd like me to do differently, please say so, and I'll try my best to do so. Okay, stay safe. Thank you. Bye.